Programming Made Easier. And we are in chapter 4, although I don't think that there's going to be much in here, so we'll see. Maybe we just write some notes in here. So, not there probably. We'll just write them at the end. Maybe. We'll see. Okay. So here we go. So installing Peerscript. This one will become obsolete fastest. That's because, yeah. Yeah, that's kind of what we hope. Okay. So yeah, and these are the tools I'm using right now as well. So and you can get them straight from npm. So never use this with sudo. Well, I think you should just avoid using npm with sudo ever. I think you can fix this by saying npm install global per user, maybe. Okay, so here we go. We can make a directory called this, and then we can get npm config set prefix apparently. So let's see if I can get this. So you should be able to see some of this. Edit. Looks like I've done this before. Yeah, there we go. So there is my prefix called node modules instead of npm packages, but whatever. And then I guess we just export some stuff and we move on with our lives. So the reason you don't want to use sudo is that npm installing a package can do like arbitrary things. And so, they could have you remove your entire system, for example, or install a crypto miner or whatever. So we shouldn't do that. And we should do this instead. So there you go. You can Google it pretty easy. Set that up and then change some. Hello? Okay. So there you go. Once you have that, it's as simple as just installing these things. And again, we're in this is 20. What are we in? 2021. Yeah, it looks like it. So you can just follow these guides. So npm install -g Peerscript. And then also Spago. And then the other one that you saw here was Peerscript language server, which is pretty useful as well. That gives you obviously language server capabilities, and I use that on my projects currently. You don't need to install that if you don't want, but we can just do this, and we should see that they are already installed. Oh, except I spelled Peerscript wrong. Poor Andre. Typing is hard. There you go. Hey, buddy. What's the matter? So now Peerscript is installed, and apparently we have some stuff that we are getting complaints about, but I rarely ever use anything but Peerscript and Spago, so I'm not too concerned about this. We could update them if we wanted to. It's not a big deal. Okay, this will get you up. I believe installing the tools locally is much better long-term strategy. The choice is totally up to you, but at least hear me out first. The reason for recommendation comes from my expertise. Working with Okay, yeah, I kind of disagree here, and mainly the reason is just that things get out of date super quick. I guess I do something very similar to this. I wouldn't do this normally unless I was like trying to get up and running quick, as it's suggested here. What I would do instead is probably use Nix personally, but Nix can be quite difficult. So maybe you would want to just use these from like your package manager. So I think, for example, we probably have some version of Node on this machine that I've installed at some point in my life. And right, we have apparently it's just a lowercase v, huh? We have some kind of npm, but we could install it from various things. So you know, in this case, pacman-ss npm, for example, or Node, I guess, and you can get Node from Arch or Ubuntu or whatever. Avoid doing these kinds of things. What is this? You can install N. Well, that's interesting. I didn't know about Git.io, but I don't usually do these kinds of curl pipe to bash type things. I think the only time I've ever done this is with Nix, and well, maybe not the only time, but it is suggested with Nix to do this. So anyway, I have no idea how to do anything on Windows, so like I can't give you any viability for these commands. I don't ever plan to use Windows for anything other than games. Okay, so anyway, we got Node and we got npm, and we could get npx if we want. I don't exactly remember the difference between npm and npx at the moment, but that's fine. So if we want to make a project, actually, let's just go back because I'll do it on stream, I guess. We'll remove chapter 4 and we'll start there. Okay, so I don't know exactly why we're doing this here, but okay, fine. All right, we're apparently making this with npm npx. What's do I have npx? I'll do it like it says in the book. This is not normally how I would do it, but that's, you know, it's suggested to do it this way, and, you know, they have more Peerscript experience than me, so this is one way to do it. Okay, so let's make dear chapter 4. Oops. Okay, npm init -y. Okay, so we have that. This will create a file called package.json. Okay. So I assume we just... All right. So we'll just copy this because I don't want to. Or live dangerously. Do you want to live dangerously? I do. Okay. What versions did it install? It doesn't even say. .14.4, so we're still pretty close to that. And 23, so just minor updates from these things, so probably fine. This will tell npm that packages are only for development. Okay. I don't use npm, so I guess that's kind of useful. To verify. Okay. So npx pers. Back from vacation, so I can't type. So I guess npx just is like a tool to make sure you're running from the right place. Because if I run pers -- version, oh well, okay, we're running the same version, so this is a bad example, I suppose. Anyway, that's probably fine. I wonder if Spago is not exactly the newest, although we did just install it. Does npm auto... Okay, there we go. So that's 20... No, it was 23, wasn't it? Yeah, okay, never mind. All right, so there we go. We got those things. Yep, we can run this fine. And then we can run npx spago init. So this will put all of the Peerscript related stuff into place. So we did the this does the node stuff, so just our development environment, and then the packages.dal and spago.dal are from npm init. Spago init, and then we have a source and test directory, and this is basically just storing Spago and Peerscript for now. Okay. We'll skip git init because we're already in a git repository, but I think if we do git status, we should have okay, so this got rid of that. Good. So we're fine there. I didn't realize it put that in there. I would imagine that npm tool put the git init in there as well. So that's good. Okay, we did that. Great. And then we can run our build. Again, we don't really need npx if you don't want, but it is what it is. And then, cool. And then we can run nps spago run. So one thing to note is that, like the Peerscript language server that I was using works best when you build once and then open up the, start working on stuff. So just something to keep in mind. Apparently it no longer prints the spaghetti emoji. Or is it like, this is just like unreadable according to, because this isn't a, like, that is definitely an emoji, but I can't render it apparently in this font. So it is what it is. But yeah, normally it's like a little spaghetti emoji. I should figure that out, I suppose. All right, second project. So we npm init, we npm install, we git init, we spago run. Cool. So we did that. All right. Now we're talking about editors. So I'm using Vim, obviously, and my Vim config is available if you want it. NeoVim setup. My Vim config is weird though, so just be aware of that because I did. Yeah, it's in Fennel. It's written in Fennel. So there's like a step. Anyway, I don't want to explain this that much, but if we look at, I think it's just our plug.fennel, you'll see that we use, where is it? Well, okay, I guess it's just here because there's no separate plugin. So I'm just using the built-in NeoVim LSP config, and you can just use that to do this kind of stuff. So there's the plugin that you need, as far as I know. That's the only one you need to make this work. The other thing is we have this Peerscript Vim plugin that basically does syntax highlighting, as far as I know, and that's probably it. After that, I think that's it. And then the other piece that you need is in here. Again, this is Fennel, so it looks a little weird, but you need to make sure that you attach the Peerscript language server to the LSP. So that's what this is doing. I know it doesn't quite look the same as you're used to, maybe, well, probably, but that's what it does. So there's only one. Yeah, anyway, I don't need to explain the caveats here. It's just, that's what's there. You should just look this up online. Someone has this in not Fennel, so you don't have to read a Lisp if you don't want to. You can also just like run it and convert it if you want. Anyway, so here's some extensions for Visual Studio Code. There's apparently one called Peerscript IDE, which I think just runs the Peerscript language server behind the scenes, or maybe it runs that other tool PSCID. I'm not sure what it does exactly. So it might run PSCID. That's what it is, right? PSC. I don't have that. So anyway, I don't remember. I don't use that very often, but I'm guessing that this is this is just syntax highlighting, and this is like the IDE piece. So there's also, you could just use the language server as well, which again you can probably find stuff online for that. Okay, so this is VS Code. We're not doing this, but like it's just kind of showing you how you can set up your paths for this particular module. Great. And then cool, we get, we get that, which we should have already as far as I know. See, so there's log coming from the LSP, so we can just, get that, and we can like look at the types of things and that sort of stuff. So again, this is Visual Studio Code, but that's that. All right. The tab sizes, don't care. Like you choose what you want there. Snippets, okay, cool. So VS Code does snippets, nice. Yeah, so this is like something to allow you to write the for all syntax, which is cool, I guess, but I tend to just write for all out. That's just my opinion. Okay. I'm kind of surprised that he goes into this much detail about for all, but and wants to use this everywhere, but maybe it's just a style thing because it is shorter. Okay, anyway, doesn't matter. More VS Code stuff. Cool. Here's an extension that you can use. I don't really care about. Anyway, this was all VS Code particular or specific. So if you don't have VS Code, then that's not all that useful to you. Hopefully, me just showing you a few of the tiny things that I use for Vim are helpful. I'm sure there are differences when you look at Emacs or Sublime Text or, I don't know, Atom. Do people still use Atom? Anyway, all right, cool. So that's chapter 4. Great. We did chapter 4. Okay, what time is it? It's 8 o'clock. So we can probably start chapter 5. So make dear. So here's the other style of creating a project. You just spago in it, and then it just creates the things that you need. You'll note that there is not a package.json there, and it doesn't create one because you don't really need one. The only thing that package.json was doing was holding Peerscript, so you don't even need that if you don't want. All right, so anyway, basic coding. Maybe we'll actually write some stuff in here. So we haven't written much in here. All right. So Prelude is a library of commonly used functions that nearly every program will use. Unlike Haskell, you have to explicitly import this module into your code. Yeah, so there it is. When you import a module like this, all exported functions get imported into your module's global namespace. This can be problematic if they collide with functions from other modules. Excuse me. Let's assume we have a module called another module that exports identity and do something. If we import as follows and then try to use identity, we get a compiler error. This identity apparently can exist, or well, it does exist in Prelude and can exist in another module, and in fact it does. So here's like conflicting definitions are in scope for value identity from the following modules. Cool. We can also do like selective imports where so like in in Haskell you would write like qualified. Oh wait, no, not for this. Never mind. I'm thinking of something different. Um, so this is just qualifying do something imported from another module. Cool. This one is a hiding term, so you can say like, look, I don't want identity from Prelude. I want identity from another module, which you're allowed to do. Cool. Um, yeah, so there's like a trick also in Peerscript where you actually can only, or it'll complain if you have multiple like open exports like this. So you see like, here, let me, so module effect console has unspecified imports. Consider using explicit ones. Well, that's kind of like not really. But anyway, you can see how there's a warning all of a sudden because there are two of these that are completely open, and if you do one as qualified and leave one open, the warning goes away. So this is like one of those things in Peerscript by default you want to try to do. The other solution to this is using like specific names for stuff. So here's an example. Yep. So now in this style, you can leave this one open because you're qualifying everything as AM. So this is another module identity, and then the compiler doesn't have an issue with figuring out which identity to use because it's qualified which one you're going to use. All right. So exercise. We could use the project that we created in the previous chapter for coding the coming exercises. Let's make our main module look something like the following. Okay, so we have effect console. We don't need console log. We are not going to. We're not going to have a separate module as chapter 5, but like maybe we will. So let's just do it. Import ch. I think, gosh, I was on vacation last week, so my typing is not very good. Chapter 5.test apparently. So we can do this. This won't compile because it doesn't understand what chapter 5 is, but we could easily just source ch5.pers. I almost wrote .hs, which is kind of funny. And then module ch5 where test is gotta be effect. Oh, wrong way. We want that one. And unit, I think. Log. One. Oh, because I don't import Prelude, it doesn't have unit. That's kind of what's going on here. I don't have a formatter either, apparently. Okay, cool. So we now have this, and we also have not an editor command. Weird. So we have this now and our separate module, which I guess this is where we're going to work, which is fine. So it says we must have a main module with a main function. Cool, we have that on the right tab there. We import our code module as ch5. Cool, that's where ch5 is, and right now it just has one function called test. Don't worry about the type signatures just yet. Okay, I won't. We call it test function in the chapter 5 module. That's where we're going to put our code to test our versions of some of the prelude functions we're going to write as exercises. Yep, and then we created this file, and we're going to put some code in here. So we have basically It's kind of funky. I gotta get used to that. So I switched to a different auto completion engine, and it's kind of interesting so far. All right, so we're just gonna log test. Okay, cool. So now we're set up. We define a name, define and name our module. We import the unit type because we're gonna write our own function, our versions of many of Prelude functions here. We don't want name collisions. Cool, makes sense. 3, don't worry about these lines, but I mean, generally these aren't that complicated, right? We're importing this from effect, and we're importing log from effect console. Maybe we don't know, like, we don't know what the effect type is, but we're going to learn about it later, probably. All right, cool. And then if we run this thing, I'll do that down here. This is going to be functional programming made easier, and then we can just spago run. Oh, chapter 5. Spago run. Okay, cool. So it just prints test because we just ran this function which logs test to the command line. Cool. I don't know that that is meant to be highlighted, but maybe that's fine. And then, okay, so since we're going to be writing a lot of functions that already exist in Prelude, we should get used to looking up the function definitions. Yeah, Pursuit is amazing, very useful tool. Okay, so here's, I guess we're going to start with flip, maybe. The function's type signature is flip for all a, b, and c. Given a function a to b to c, and a b and an a, I'll give you a c. Okay. I've used, yeah, okay. We want to understand what this function does, and sometimes we'll get a nice example, other times not. So flip const 1, 2 is const 2, 1 equals 2. Yeah, well, when applied to some other thing. Yeah. Unfortunately, we don't know what const does just yet, so this is marginally helpful. It says that calling flip on the function const, whatever that does, with parameters 1 and 2 is the same as calling const with those parameters reversed. It also shows the result of const being called on 2 applied to 1. Another thing to notice is, I don't know why I'm reading this verbatim, but it's probably because I'm a little tired. Cool. Okay, so writing flip. Sometimes a function's parameters are in the wrong order for how we'd like to use them. This is where flip comes in. Try to code flip in the chapter 5 module and then write the following line to test your function. Okay, so we want to write flip. So flip for all a, b, c, b to c. And it gets an a first, right? I guess it doesn't matter which order you do it, but so we're gonna get an F, a B, and a C. And we need to write F, C, B. Well, I shouldn't write it like this. I should write A. So it's not confusing. So that's flip. And then if we want to test this thing, we apparently can just do this, which isn't really a test, but right. Okay. So if we run this, we should get 2, and we do. So the idea here is just that the 2 matches the code there. Nice. And So this is kind of again, this is a weird test, but it is what it is. So prints 2. All right. All right. Hint. Let's take a look at the details of the type signature. It tells us that flip takes a function of 2 parameters, A and B, returning C. A parameter of type B, a parameter of type A, and returns a value of type C. Our first step is to name the parameters. So, yep, we could do F, X, and Y. So typically, this is like a really common way to do this is instead of naming, like your types are named like A, B, C, D, and then X, Y, Z. What would be next? Probably like S or something. I don't know. It's weird after that. Hopefully, you don't have enough, like too many parameters. But typically, like I would try to keep these the same style. So if this was a B and that's a B, like I would put this, these would match, and I would probably put this as Y and then this as X, just because it matches like A and B. Gosh, typing. And then we can say X, Y like that. So if we want to do more like this style, this is how I would write it personally, only because B comes after A. Not that it doesn't matter at all. It's just it's more for the reader than uh for the compiler. The compiler doesn't care. So yep, we call F with the original parameter order flipped, cool, and then we can just run this thing. It prints out 2, awesome. All right. What would have happened if flip's type signature had the redundant parentheses added? Now it takes a single function and returns a function. Yeah, so we can do this, but then you can see we have to turn this into a lambda to make this happy, because it really only takes like one input. But remember that these are completely equivalent. So this and this are perfectly equivalent. So you can write it in sort of the simpler style if you prefer. Yeah, this is just a lambda which takes 2 arguments, and then like you could sugar this even further if you wanted to, right to um, like that. So this is still sugar, um, but you can desugar it yet again to form that. Again, we can also do like different parentheses. So if you want to do it like this, where we take an explicit B, then we have an A to C, you can do it like this, and cool. Yep, all versions are equivalent. They do exactly the same thing. The only thing that changes is like where you put the parentheses and sort of how many parameters the function expects you to pattern match on, basically. Okay. We can look up const, but I kind of know const as well. So const is gonna take a b, and then we're going to take a b a. Let's use the style of naming that they're doing there. I'm pretty sure that that's const. Oh, right. And now we can remove this, and there is const. And this should still work. We've replaced the definition in the prelude with our definition, and we should be good. So what does const do? We take 2 parameters, A and B, and we forget about the second one forever. So this is a surprisingly useful function, actually. You'd think that it wouldn't do that much, but it actually is pretty useful most times. So there we go. So we give it a shot. we ignore the second parameter and we just return x. Cool. So we ended up writing it pretty much exactly the same. The only difference is obviously he's using this for all syntax, which is fine. All right. All right. If it's not obvious how this is useful, maybe a simple example will help. This is kind of a weird example, but like if we have a filter function where we say, give me all of the n's greater than 2, we would only get 3. But if we just wanted to like return the list, we could write const true, which is just saying like, always, no matter what you give me, return true. And so when it gets a 1, it returns true, and therefore it's returned. When I give you 2, you return true, and it's returned, etc. So const true is pretty useful. It's not a useful predicate, basically. Const true and const false wouldn't be a useful predicate, but they are technically predicates. I'm trying to think of like a good example of when I've used const offhand, but it comes up occasionally and it's pretty useful. Okay, cool. Oh, okay. So this is interesting. So there's a really helpful operator that is often used in idiomatic Peerscript, the $sign. Yeah, it's very easy to implement. We'll do so shortly. It's powerful in reducing noise. So like as an example, what we can do with $sign is I can show you how it works, and then we'll code it here in a second. So basically, we just remove. You can use it to remove parentheses. So yeah, we're getting unknown operator because we haven't defined it. You could import it directly from Prelude, so it's not a big deal. But the general idea here is that we could replace these parentheses with $signs, like so. And I'm actually not sure how to define the operators in Peerscript, so this is going to be pretty useful. There's like you have to define its fixity, or not its fixity. It's first we need to write its underlying function apply. Okay. Okay. Let's look this one up because I think it's just gonna be and also we should like follow the book when we can. So we're gonna take this function and then apply. Is this the right apply though? Probably. We take a function from A to B, and then but this is an apply F. It's got to be this one. Yeah, there it is. So you can see the $sign is operator alias, so it's the right one. So here's the type signature. Let's just grab it so we don't have to type it. So apply is going to take an F and an A. And the idea is we're going to evaluate whatever the A is first. So I don't really know how we do that if there's some trick. If there's some trick here. Okay, you'll probably see apply as the first. Yeah, so this is a different apply. This is the applicative apply, which we'll learn about much later. Okay, there are two apply functions, one in control apply and the other in data function. We want the one from data function. Okay, cool. We could alternatively look for $. Cool, and then go from there. Great. So here's the. You might think it's a pretty useless function. It looks kind of useless, but okay, so it's applied exactly as I expect it. It's just the way the operator works that's fancy. So it's going to be infix our dollar apply 0 or something. I don't remember how this works. So we want the parentheses to associate to the right. It looks like I dropped a bunch of frames randomly, so hopefully it wasn't too bad. Sorry about that. All right, so we want things to associate to the right because we want the things on the right to happen first. So it's clearly infix R, and then it said 0. I think it said 0. Right associative precedence 0. Yep. So there's your precedence. And then we take apply as dollar. Okay. And then that fixes things. Now, the piece that I have to understand. Okay, so higher gets done first. So 0 means it always gets done last, which means that everything to the right will evaluate first, and then we'll like go back up the chain. So this flip const 1, 2 will get evaluated, then show of that will get evaluated, and then log of that will get evaluated. Cool. Where's the backtick? Oh, right there. Okay. So cool. So let's put some notes here. So right associative higher what is it called? Precedence. Higher precedence comes first. And yeah, something like that. That's how we define infix operators. Very cool. Write the function and then write the thing. So I'm not used to this because in Haskell you don't have to do this. You just define dollar, but I forget how you define its precedence. I would have to look that up, but I'm not going to at the moment. Yep. So infix R 0 apply as dollar. So it's basically allowing this a parameter to behave differently. So we're just applying in a different way. All right. So you may be wondering how we knew what to choose for associativity and precedence. For this operator, it's a pretty simple process, which is not true for all operators. So if we think about the precedence of parentheses, it would be precedence of parentheses. It would be 9. Apparently, that's a number from 0 to 9 because it has the highest precedence and therefore gets evaluated first. Oh, I see. The parentheses themselves are a 9, which means they come first. That's why. Okay. We're saying that we want everything in the parentheses to happen in first. We want flip or this to come first and log to come last. Cool. Yep. I've kind of said this in English a few times, but that's it. Well, I've said it out loud, but there it is in the text. Mm-hmm. Cool. All right, so writing the apply flipped operator sharp. So there's another very helpful operator in Peerscript, sharp or octothorpe or whatever you want to call it. But it's a little more difficult to understand why. So let's look at an example. So we have step 3, step 2, step 1. Here we have a function that performs 3 steps, but the order in which we write these from left to right feels inside out when compared to the order of execution. So we could write this using the the $ operator like that. But we would prefer maybe to write it in this style. So this is just another style of writing. Okay, so can we just say like, okay, so we need to define a function of apply flipped. So we're going to take a value. So A to B to B, I guess. What is it, buddy? Oh, that's kind of annoying. But I mean, I understand why it's doing that. It's just a little annoying. So it should be just flip apply, I guess. And then we should be able to write infix R0 apply flipped from chapter 5 as sharp. So then we should be able to write, I guess, flip const 1 2 sharp show sharp log. Sorry, octothorpe. What does this say? Unknown value discard. You're probably using do notation. Okay, so get from prelude discard. So we can't actually do this, but we could do this, I think. Do we need discard if we do this? Yeah, we do. I've not really messed around with discard much, but I assume that it's just removing that thing. Okay, so anyway, we only have like 2 steps here. We have this one step and then this step that we're applying to 1 and 2. So it's kind of tricky here because we can't use log because it produces an effect. So this still has to be on the left side of the dollar, and then we could do it like this. So we're just kind of flipping the order, flip const 1 2 sharp show versus show $. So I think that like depending on what language you're used to, one of these might feel more familiar than the other. I think that a lot of languages do something like this, where there's like, do a thing and then dot some other function, dot some other function, dot some other function. So maybe sort of this forward composition will be more useful or more obvious, I guess. But in Haskell, you tend to do things backwards like this more often. So I don't know. I guess you just get used to it. All right, so I'm pretty sure that that's right. Maybe there's some trick that I don't understand that we'll see here in a second. There's apply flipped. Okay, so we have to think about operator precedence. So this actually is probably infix L, right? Because we want to we want to do, well, this is an A. So that's this, and then we want to put that in parentheses. All right. So yeah, I think it's just this which has the something is wrong with the precedence, I think. All right. So determine precedence. Let's look again at our example uses of sharp. Cool. Imagine that our x is more complex computation, for example, x plus 10, which is what we're doing here. Like this is actually more complicated, which is why it's causing problems. So I think that this needs lower precedence than function application, but I don't know what the precedence for function application is. So if we're wait, it needs wait. Okay, let's think about this. If we were to replace x with x plus 10, we'd want the computation to happen before we apply it to step 1. The parentheses will guarantee that x plus 10 happens first. We don't really want to have to type in the parentheses if we don't have to. This means that we want the precedence of sharp to be last. Based on all this, we choose the following operator definition here. Okay. And we could live with this definition for a while, but when we use it in the real world, we're going to eventually bump into a compiler error. Is that actually what it says? Yep, cool. So there it is. Sharp is infix L, dollar is infix R. The compiler. So I gotta write this one down. Hang on. I try to send like any mistakes I can find to Charles. So we're on page 139. What time is it, by the way? Okay. After compiler error image the compile should be the compiler. Okay. I'm kind of I'm keeping those in a spreadsheet, and then I'll send all of them at once, so I don't have to like I don't want to send him like one at a time. So anyway, the compiler is forcing us to add explicit parentheses, but the whole point of dollar was to reduce the reduce parentheses, and now our definition for octothorpe is rooting that. How do we fix this? Okay, so that means that there's two things we can do to fix this. Change the associativity so that they match. Change the precedence so that they're no longer. And 139, number 2. Air. To there. No. Okay. Option 1 is out, since it would completely change the semantics of the operator. Yep, that's correct. So option number 2 is our only real option here. Yeah, okay. So just change it to 1. Sure. I'm fine with that. That seems reasonable to me. So it's like do dollar last and then do sharps before that. So this will always happen before a dollar sign. I think that's totally fine. Makes sense to me. I don't think about these that much, and maybe like when I'm doing more Peerscript, I'll think about them more, which will be good because, uh, like this is even new to me. Not completely new, but somewhat new. So maybe we'll define more binary operators in the future and just keep practicing that. I sort of just understand the semantics for this one versus this one, like when I use them in Haskell, but when I've not defined them myself, but it makes sense that you would use 0 and 1 after being told that, I suppose. Kind of unfair. Yeah, so this one's never gonna work, I don't think. And the reason is just the way that log works. Oh wait. Oh, this is the compiler error here. So there's actually two of them. There are some internal functions that are normally imported by Prelude that are used for do syntax. Since we've decided to only import a few items from Prelude. Cool. All right, so we did that. Oh, maybe this works now? I would be surprised. Oops. Oh, wow. Okay, I wasn't expecting that to work, but I guess it does. The reason I say that is just that I guess it's a for all B, so it can do that. Yeah, the result of B is just affect unit, so I guess that's fine. Neat. All right, so it says preparing to write data list functions, which I think we're gonna leave for next time, and then we'll put this. We'll prepare and then go from there. So the remainder of the functions we'll write in this chapter will be from data list. So this will be fun because I usually love doing data list type stuff. It's just enjoyable. So we want basically a list, and we want the concatenation operator, and that's it. Spago.doll. No, not this one. Packages.doll. I think I was right the first time. Yeah, I was. Okay, so here we want to include list, I think. It'll probably tell us. So, okay, so we import this. We get that. It turns out we don't have the list package. It's just called lists. Again, we could have looked this up. It's not that big of a deal. We open up spago.doll and we add lists. So there's our lists. And then we can close this. And in our case, we just spago build because they're using npx or they're using npm to handle the compiler and package manager. Actually, it's kind of funny. They're using a package manager to package manage a package manager. Okay. You get a bunch of warnings. These are because of two reasons. First, we aren't using data list, so the import of data list is redundant. All of the other 8 warnings are because there are things in Peerscript libraries that haven't caught up with deprecated features that were introduced in version 14 of the compiler. We can ignore them. Okay, cool. So that's where we're going to stop for today. Does anybody have any questions before we call it? One thing I want to do is just write. Actually, I kind of just want to commit most of this code anyway. So we're on page 144, section 5.11. 5.11. All right. There's only one of you, so I'm not going to go rate anybody. Just kind of pointless. But I appreciate you watching, and thank you. Next time we'll start. Oh wait, nope, 5:10, and then I think that